Hello, let's continue our Sudoku adventure with Snakes and Adders by Strosahl. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have V's, white dots, and black dots. Digits separated by a V must sum to 5, so like 1, 4 or 3, 2. Digits separated by a white dot must be consecutive. So for example, 1, 2, or 3, 4, or 2, 3. Could also be the other way, 3, 2. And digits separated by a black dot, one of them is exactly double the other. We say it's a 1 to 2 ratio. So if this was a 2, we could put a 1 here, because 2 is double 1, or a 4 here, because 4 is double 2. Again, order doesn't matter on any of these. Just one of them's twice the other. Now, for none of these have a negative constraint, meaning we could have in our solution a 2 and a 3 here. And if we did, we could have given you a V there and given you a little extra little hint, but you don't need that little hint, right? So we aren't giving them all. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, so my initial thoughts about V's are always no 5s and 6s on V's. It's always either 1, 4, or 2, 3. My initial thought about white dots is not much, but black dots are interesting because there's only 3 ways to do the black dots. So there's 2 ways to do the V's. Oops, I'm in the wrong mode. Either 1, 4 or 2, 3. That's it. For the black dots, we can do 1, 2. And if you think about it, you just have to think about what's the smallest digit on the black dot, and then the larger digit's just going to be double it. So if the smallest digit is 1, we can do 1, 2. Let's just use some scratch space over here. We can do 1, 2. If the smallest digit is a 2, then we could do 2, 4. And if the smallest digit is a 3, we do 3, 6. If the smallest digit were a 4, we'd have to do 4, 8, and there's no 8 in the puzzle. You can still include a 4, it's just not the smaller digit. So these are the possibilities. 1, 2, 2, 4, 3, 6. So there's a few observations about this. One is 5 is completely missing. So we can't put a 5 on the V's or black dots, which may or may not come in handy. But also, if you don't contain a 2, you have to be 3, 6. So those are kind of the interesting things to note. I'm noticing these V's have to be different from each other. So this might be interesting. Let's just color it. So this is the green flavor of V, and this is the purple flavor of V. Why can't it be the green flavor of V? Well, what do I mean by flavor? Well, we don't know if green is 1, 4 and purple is 2, 3, or if green is 2, 3 and purple is 1, 4. But what we do know is they're different, and those are the 2 possibilities. And so we can track the V's that are different from each other. And the reason this can't be green is we end up with 3 greens in this box. But remember, green is only 2 digits. Can't have 2 digits spread across 3 cells. So what I'm noticing is kind of a roping argument here, which is that this green ends up here. So this is a green. And then the 2 purples end up here. So this has to be a 5, 6 pair. This green, so this can't be green because it would be 3 greens in the column. So this is a purple V. Curious. This has to be a green V because of the purple here. I'm trying to translate it down to here, but I'm not sure how. Okay. We know these 2 are different. It's the same deal. So let me see if we can utilize it. Let's use 2 different colors for a second, orange and blue, just to show that they're different. We don't know whether orange is purple or green yet. We're trying to figure out. So we know that this one's orange, and that immediately tells us it's purple. Okay, because it's in the same column as this green. So these are purple, and then these are green. So all the V's are colored. Let's see if we can propagate further. Yeah, we have 2 greens over here. So now this has to be 5, 6. Why don't we just use orange just for the ones that aren't green or purple, the 5s and 6s. So we'll end up with 3 different colors. So the 5, 6s go here. I'm going to mark them as 5, 6 though, because it's just 2 digits. This is also an orange 5, 6. Okay, and remember, we can't put a 5 on a black dot, so this ends up being 6, 3. And so now we know that all of the greens are 2, 3, and all of the purples are 1, 4. And so this ends up 2. 2 can't be next to 4 on a white dot, so this is 1. 1 has to go with 2 on a black dot, so that's 3. 3 has to go with 4. That's 1. We get the 5 and the 6 resolved here. This is 4 and 1, which forces this to be 2. That forces this to be 1, and that's 4. We get the 3 and 2 here. We get the 3 and 2 here. I think the colors have outlived, but you know what? Let's just keep coloring anyway. I was going to say outlived their usefulness. This is a 3, so it's green. And so this is the other orange, which is 5. These are 4, 5, and 6. So the 4 has to go here because of this 4. So that's purple, and this is an orange 5, 6. This is 1, 4. Oh, we know the order. That's 4 and 1. So I guess we could fill these pairs out. This is a 4, 5. Yeah, we already know. Okay, so that's the 4, that's the 5. So that's purple and that's orange. And then this is a 1, 6. So this is the 6 and this is the 1. 6 is orange. 1 is purple. All right, I need a green 3. Yeah, so this is green, and because this can't be 3. And then this is orange. I'm trying to finish the coloring before you finish the numbers. So we're missing a green in this column, and we're missing a orange in this row. Okay, perfect. So this 6 tells us that's 5, 6, 5, 6, 5, 6. This is 2, 3, and we're done. All right, cool puzzle, Strosahl. I enjoyed how we could propagate the coloring of the V's. That was neat. And then the dots kind of, this dot here, 4, 6, 3, resolved everything. Very cool. How'd you do?